Hello everyone and welcome to lecture 9 of the BSc IT Python series. Today's lecture topic is files. So let's get started. Here we will go to the second slide and here we will see some points on what is a file. First point being file is a container of data stored in a persistent storage hard drive which can be accessed later. Next point is it can contain structured data like CSV, JSON, etc. or unstructured data like free text. Mm, Third point being the size of the file can be small like 1 KB or large like 240 GB. So here when we create a file there is no constraint on the size for the file. We can create a file of any size. Next we have a text file has a .txt extension. The extension specifies the structure of the data in the file. What I mean by this is for any given file, if we are focusing on the extension of a file, we come to know that what kind of data would be inside the file. So in case of .txt, we will have a free flowing text, and in case of .csv, we will have comma separated values. So that is the major purpose of the extension. Further, we have a point that files are crucial when we need the program to have persistent data. It can be used to save the program state and also be an input to multiple programs. So what I'm trying to say here is that to this point, we have only seen transient programs, which means where we are not storing the output. But using files, we can store the output and then use the program's output in another file, or we can just treat it as a static data, which can be stored in either a database or we can serialize them using pickle module. Moving on to the next slide. First, we have what we have here is what is a text file. So a text file is basically a string of characters combined together with not specific structure or length can be termed as a text file. This is just some description about the text file. Then we have the extension of a text. So the extension of a text file is .txt. So I did go over this in the previous slide. And we can read the text file using the open construct. So on the left you can see the program, and what the program does is basically it opens a file. Here it's specifically a Python file. We can provide the text file also. So here we are reading the file and then we are trying to read all the lines using Readline method, and then we are trying to print all the lines which are read using print function. So on the right you can see the output for the program. So this is a list and it contains all the lines from the file. It contains all the lines from the file and the elements are separated by comma, so that's how I know it is a list. Moving on to the next slide, we have attributes of file object. So what is a file object? A file object is basically a pointer to the current file which is on which the operation is being performed, and here we will see what attribute exists for a given file object. So basically file object has multiple attributes like encoding, encoding mode, name, etc. So what we have here is following is a list of most used file objects. First is the closed, which specifies that whether a file is closed or not. If it is true, it means it is closed. If it is false, it means it is not closed. So that's why it is having a Boolean value to emphasize that particular status of the file. Next we have encoding attribute, which specifies the character encoding which was used while creation of the file. So here I have opened thinkpython.pdf, and if we check the encoding for this file, it is CP1252, which is the encoding which was used while creating this PDF. Next we have the mode attribute. So the mode attribute tells us what input output mode is the file currently open in. So here when we check the mode of this file object F, it is currently open in read mode. Um, yeah, by default, any file opens in read mode. If you want to open the file in write mode, you have to specify another parameter after the file name inside inverted commas. So to open the file in read mode, you have to specify W. Next, we have name. So here, say if the file object was created using open, it will be the name of the object. So if we check the value of the attribute name, it will be think Python because we open the file using the open method. We are having the value as thing python.pdf. If we didn't open the file using the open method, it would be the source of the file object. So I'm not pretty sure how this works, but this is just a theoretical knowledge, and mostly when you'll be working with file, you will be using open method. Next, when we move on to slide 5, it is popular file methods. First, we have close method. So what close method does on a file object is it closes the file for any further operation. Next, we have the next method. So basically, next method um, is used to advance the file pointer inside an iterator. But if you try to use this next method outside an iterator, it will not work and you will error out. So while reading the file using next, how would you know that you have reached the end of the file? So that would be through stop iteration exception, which would be raised when you hit the end of file. Using that, you can terminate your file reading and you can move forward. Next method we have here is the read. So read is basically used to read size number of bytes from the file, and here we can see that inside the round brackets we have an parameter which is size, which we need to pass when we are calling read method on the file. Next we have the readline method. So what does this readline method do is it reads one line at a time from the file, and we don't need to specify any size value to the read line. So that would be, yeah, we don't need to specify any size value to read line. Further, we have seek. So what seek does is it moves the current file pointer position to the specified offset based on the whence, which is point of reference. So what I mean by whence is it can take value as 0, 1, and 2. And when we set it to 0, it sets the reference point at the beginning of the file, which means if I specify, uh, maybe I should give an example here, seek 23, 0, it means, sorry, f dot seek, it means that starting from the start of the file, add 23 bytes to the position of the pointer and give me the output. Not give me the output, but yeah, move the position of the file pointer 23 bytes ahead from the start of the file. Yeah, that's good. Next we have uh, 23, 1. It means that starting from the current position, move the file pointer 23 positions ahead, or I should say 23, yeah, 23 positions ahead. Then we have 23, 2, which means that we need to move the file positions 23 points back from the end of the file. So that is what is being specified by 2, which is the reference point. Next, we will move forward to 6th slide, which is some more continuation towards the popular file methods. Here we have tell. So tell basically returns the current file position pointer. Nothing advanced here, just a number which is being written by this method. Next we have write and write line. So what write does is writes the specified string inside the bracket to the file only when the file is opened in the write mode. And what write lines does is it takes a sequence being a list, a tuple, or any other sequence, and it will write those lines to the file. So at the end of the slide, what we have on the left is the text file, and on the right some methods being called on the file object for this text file. So here we'll go line by line and look into the output, what is happening here. So first we have f is equals to open test file.txt. This is opening the file and giving the reference to the file in f variable. When we try to do f.next, we get an attribute error. Why? Because this is currently not being operated inside an iterator. So that's why it is being errored out. We cannot call it explicitly. Further, we have f.read where we have specified inside the method to read 2 bytes. So we can see that we have read 2 bytes from the file. If we specify 20, this would be the output. Next we have readline. So what readline does is it only reads one specific line at a time. And we have f.seek. So f.seek from the current position to move 2 bytes ahead. But I would say this operation is not supported on the text file. The reason being that the conversion of the offset number to the bytes is not quite accurate for the text file, and this might happen for many other files, but currently this operation is not supported on the text file. If we move ahead to the next method where we see f.seek and only one number, so here we are trying to move 2 bytes ahead starting from the start of the file, so it is seems to be supported, and we move 2 bytes ahead. If we try to get the current position of the pointer, it will be at position 2 and it is open in reading mode. Now we are on to the write method. So remember, when explaining write method, I said that you can only use them when the file is open in write mode, but currently the file is open in reading mode, so we are unable to write the specified string test line inside the file. That's why we are getting unsupported operation. We will move on to next slide where we'll see what is a directory. So first one says that a directory is a container for any kind and size of files. So first we saw that file is a container, but it is a container for the data, and directory is a container for those files. So it is kind of a hierarchical structure that inside directory we will have files, and inside files we will have the data. Next we have the point that directory is helpful in establishing a tree-like hierarchical structure. So this is helpful when you're trying to establish a directory structure for accessing files in a given fashion. For example, all the files for a particular year should be grouped in one year, and for a month should be grouped in one folder. So this is how directory helps in organizing your files. Sometimes we also call the directory as folder, but nothing changes. It's just a change of name. All the functionalities and every other thing associated with directory remains the same. So no worries there. And I think that's it for this lecture. Thank you so much for watching this lecture on files. Stay tuned for more lectures. Please subscribe the channel for notifications regarding new uploads. Press the like button if you like the videos and want me to make more videos like these. Dislike if you do not, and please leave comments in the comment section so that I can improve my videos based on your comments. Thank you so much. You'll find these slides uploaded on GitHub where you can download and read them at your own pace. Once again, thank you so much and have a nice one. Bye for now.